Okay, so I've given you here a big number. So if you look at it, it's 1,234,567.891. And I've labeled all the place values, and you can refer to this if you need to. So things to notice here, if it's after the decimal, each of these words has TH in it, right? So it's tenths rather than tens. Okay, it's hundredths rather than hundreds, thousandths rather than thousands. So the TH reminds you it's after the decimal. So what's the steps? Locate the place value to which you're going to round. And this is what I recommend, circle it. Okay, so let's say I'm asking you to round to the nearest hundreds in this number. So I circle that. Then it says look at the digit immediately. We don't care about everything to the left of that. We care about to the right. And we don't actually care about any other digits except for the one directly to the right. Okay, and so directly to the right, it's a 6, which is bigger than or equal to 5. So anything to the right that is 5 or greater, that means we round this value up. If it's 4 or less, it stays the same. So here we're doing the less one. So if it's 4 or less, leave the circle digits the same and replace the remaining digits with zeros if it's not a decimal. So you just fill into the decimal if it's not a decimal. If it is a decimal, you stop there as well. You don't have to put 0.000. In fact, it's actually incorrect because you're saying it's measured to those decimal places. If it's 5 or greater, add 1 to the circle digit and replace the remaining digits with 0. So this I would then write as 1, 2, 3, 4, 6, 0, 0. So 1,234,600. Okay, because that is, this number is 5 or greater. So let's practice. So round this number to the nearest hundredth. So look for the TH. So hundredth is the second, I'm going to make this thinner, second decimal value. Okay, there is no 1th digit. It goes right to the 10th digit and then the hundredths. And so I've circled it. Directly to the right is 3. So this is going to stay the same. And then you do not fill in with zeros afterwards, because that would be saying that you've rounded to 4 decimal places. It's only to the nearest hundredth, which is 2 decimal places. So sometimes we might say round to the nearest whole number, which is really the ones digit. So make sure you know that terminology. So now when I do this one, I'm going to circle this 5, and you can see after it is a 0. So this is going to stay as 295, no decimal point, no zeros afterwards. Okay, so you only fill in with zeros afterwards if it's anything to the left of the decimal that you're rounding to. So 10's digit is the 9 there. So now you go to, oh, no, we don't go to. Take a look. The 5 to the right of the 9 makes the 9 go up by 1. Well, 9 going up by 1 is 10, so you carry the 1 over, and that's going to be 300. And if you think about it in money. $295 is very close to 300. 295, if you're rounding to the nearest 10, then the rule is the 5 makes it go up. So the next tens is 300 if you're counting up by tens. Okay. 100 is the 2. Well, the 9 makes the 2 go up to a 3. So whether we round to the nearest 10 or the nearest hundred, for this particular number, we get the same value, 300. So then thousandth, well, tenth, hundredth, thousandth, and again, a 5 afterwards. So everything, to the left stays the same. That 5 makes a 3 go up to a 4, and no decimal after, and no 0 after that. And the nearest tenth, oops. Oh gosh, what's going on? Is nearest tenth, is that 0 there? Okay, look up one of these, please. Okay, is that 0? And there's an 8 afterwards. So 295 point. Well, the 8 makes the 0 go up by 1. Okay, so comparing numbers. You must compare the same place value digits of any 2 or more numbers, starting from the left. If the digits are the same, you continue to compare the next digit to the right until you find a place value that is different in both numbers. The number that has the largest digit in that place value is the largest number. So here, take a look, starting from the left, 3's are the same, decimals the same. So you're looking at the same place value, obviously. And then we've got a 5 here. So this one's bigger than the 4. Pretty easy, even though all the other digits are the same. This one, 9's the same, 2, decimal 0, decimal 0.03, and then this has an 8 afterwards. Well, really, you're comparing that to a 0. There's nothing afterwards. So this one's the bigger one. And then same thing here, 0.9, 0.9, we've got a 4 and we've got a 3. So that one's bigger. Okay. All right, so here's those numerical response type questions that you'll have on a test. And it's kind of funny because I teach all grades and I teach grade 12s and I still have students filling in the boxes at the wrong end. They always go from the first box, the leftmost box. So think about reading a book, writing a word. You start from the left, so fill it in that way. If you fill it in wrong on the diploma exam, so you have a couple years of practice, then your bubbles underneath will be wrong and you'll get it wrong. Now, sometimes they will go back and scan it if you put it in the wrong place, like what a common mistake is, but they're not going to necessarily do that. So you want to get in the practice. I'm not going to take marks off now. That's why we have 2 years, almost 3 diploma exams at the end of your grade 12 course to get it right. So there are 4 boxes to fill in, and you always fill them in with 0 through 9 or a decimal point. You never put variables, you never put units. It's called numerical response because it's numbers. The only non-number is the decimal that you put in. It has to be 4 digits or less. A decimal point takes up one of the boxes. Boxes must be filled in starting from the leftmost box. Numerical response answers will never be negative and never have variables. So say you get an answer on our test for this unit in integers and you get a negative answer, but it's a numerical response question. You know that you did something wrong, okay? Because you never have a negative answer in a numerical response. Now, granted, the odd time maybe a teacher makes up a test, makes a mistake or something, but guaranteed here at Wisewood, we're pretty good about that. It's not really going to happen. So say to yourself, oh, I got a negative. It's a numeric response. Maybe I better go check. Okay, it's kind of a way of checking some common errors. So let's do this one. This is rounding to the nearest tens digit. So I circle the 3. So 4 stays the same. The 8 after the 3 makes the 3 go up to a 4, and then I fill in. Okay, I don't fill in decimals afterwards. So I fill this in starting from the left. And you'll notice if you thought that maybe I should put in decimal 0, you're going to run out of space. And so that is a check that you don't do that, right? It's almost a way of helping you. Okay, so nearest 10 digit, 438.9 is really close to 440. Okay, nearest whole number, so the 6 here, well, 6, take a look directly to the right, it's a 4. So this stays as a 6. You don't put in decimal 00. And you don't, a common mistake that I've seen students do with 6.45 is they'll start rounding all the way from the right-hand side. So they'll go, oh, this 5 makes this 4 go up to a 5. And then that 5 makes this 6 go up to a 7. Think about this as if it was money. $6.45. Is that closer to $6 or to $7? $6. So that's another, if you think about money, most of us can know about money and can figure things out a little bit easier. Okay, so next one is an integer question. So we talked about that yesterday. -4 in brackets squared is positive 16. And then subtracting a -5 is like adding. So that's 21. Okay, if you said, oh, -4 squared is -16 plus 5, you would have gotten a -11, and you should know that that is incorrect because you can't have a negative in a numeric response question. We would ask you to show work for that type of question in a written response, or maybe a multiple choice where one of the answers was negative if it was supposed to be. Okay, so that's how you fill in those. So a review of rounding and a review of numeric response, because sometimes it might be a different concept that we're working on, but you get decimals. Say it's an area question with a circle. You're going to have to round. So yeah, we're learning that concept of area, but to put it in a numeric response, you have to round, or even a written response, and you want to round correctly, because we'll take marks off if you don't round correctly. Not so much in this course, but like for every question, because we do a lot of rounding, a lot of decimal work in this course, so kind of don't take as many marks off, but in 10C, 20-1, 20-2, absolutely. Okay, for every question. So again, without a calculator, I want you to try to add and subtract. So I've given you the steps that I use. I know there's different methods for adding and subtracting that you guys learn now in elementary school, but most common sort of traditional way is to align the decimal places vertically, add or subtract the columns depending on the question. And for adding, you may have to add a 1 to the column to the left if the sum of the digits is 10 or more. Subtracting, you might have to borrow 10 from the column to the left. Oops, I have too many columns here. From the column to the left. Sorry. Yeah, so here I would line these up. So I'm not lining up the numbers, I'm lining up the decimal places, the place values. So the lining up the decimals really helps. That's the first thing. And now I'm adding. So this is like a 0 here, right? Trying to do a 0. So 1 plus 0 is 1. 3 plus 9 is 12. So there's my 12. I put a 1. That it goes into the next column, right? Because it's more than 1/100th. So now that's 1 plus 0 plus 7 is 8. Copy down the decimal. 4 plus 1 is 5. 2. Okay. And always in your head, think, does that make sense? I'm adding about 4 with 21.79, about 22, which is about 26, which if I look at that number and round to the nearest whole number, it's about 26. So that's a ballpark. It doesn't give you the exact answer, but do some estimating, because if it isn't close, then maybe you didn't line them up correctly, right? And same with the next one, we want to line up the decimal places. Okay, and so here you can see that it's like having a 0 above there. So I can't, there's no negatives within a subtracting. You might get an overall negative answer, but we're keeping these as just decimal, positive decimals that we're adding or subtracting. So here I have to borrow 10 from here. So that becomes 6, and that's now 10. Minus 2 is 8. 6 minus 3 is 3. Again, I can't take 6 from 2, so I'm going to borrow from the next place value to the left. 10 there is 12, minus 6 is 6. Copy out the decimal. 8 minus 3 is 5. Okay, if the first number is bigger than the second, of course you're going to get a positive. And then if you think about 9.27 is about 9. Or if you just look at this, 9 minus 3 is 6, and there's other parts to it, that rounds to 6. So you know you're in the right ballpark. It doesn't mean that it's completely accurate. You need to go back and check just to make sure. Okay, multiplying decimals. We're not going to do dividing, because really, for most of this course, you will have a calculator. Certainly when we're doing decimals, most of the time you'll be allowed a calculator. We're just doing this to try to get your training gear after the summer, okay? And so we're leaving out the operation of dividing without a calculator. So multiplying digits, the decimals, I should say, again, same as you may have learned different methods when you were in elementary school, junior high. This is the traditional method. So you line up the last digit. So I always put the one that has the most digits first. And then if I've got 1.8, that's 2 digits. So I line up just the digits. Okay. Now, if you have a different method that you've learned in previous years that you like, you can do that. But this is the more traditional one. So now you multiply the last column together, carry any 10s to the column to the left, and continue multiplying with the digits of the top number going to the left. So you're always going to the left with your multiplying of 8. Then you do it with 1. So this, 8 times 6 is 48. So I show the 8 of the 48, but I carry the 4 in the left. So really, if you look sideways, you see the 48. Then I multiply 8 times 3 is 24, plus that 4 is 28. So again, there's my 28 if I look sideways. 8 times 7 is 56, plus 2 is 58. Lots of 8s. Then for the next number, the 1, I start underneath the 1. So I'm going to leave put a 0 there, or you can leave it blank. And then multiply every digit in the first one by the 1. So that's going to be a 6, a 3, a 7. Then we have to add those 2 rows together, just like we added previously. Carry the 1, 12, carry the 1, 12 plus 1 is 13. And then you count the total number of decimal digits in the original numbers. So there was 1, 2, 3. So now there's 1, 2, 3. And so my decimal goes, oops, let me do it in blue. So that there's 3 decimal digits. Okay, so you try the next one. I would put the 21.4 at the top because it's got 3 non-zero digits. Okay, so there's part B. Think about estimating this. So if you have about 21 and you're multiplying it by 0.35. Well, 1/3 is 0.33, well, 0.3 repeating really. And so 1/3 of 21, you remember your times table, 21 is 3 times 7. So 1/3 of 21 is 7. So that kind of makes sense. We've got 7.49. Okay, you've got, at least you've got the decimal point in the right place. Maybe you've got some of the digits incorrect, but
close. Grade 10, surnames P, Q, and R. Grade 10, P, Q, and R.
Any of this? Yep, go if you need to. Okay. Okay, so we are now going to look at fractions. Again, trying without our calculator. Fractions, the biggest thing for adding and subtracting, you have to have a common denominator. And students just struggle with this so much. So I will see on a test sometimes the answer to this being 4/6. Okay, which is 2/3, and that's incorrect. So sometimes I like to think about maybe pizza or something like that. If you eat half a pizza and then you eat 3/4 of a different, so you have two kinds to choose from, right? You eat half of the Hawaiian, 3/4 of the vegetarian. You've eaten more than a whole pizza in total, right? Think about what that looks like. This says you've eaten 2/3 of it. So that doesn't make sense. Okay, what you want to think about is cutting the pizza into the same size pieces. And then, so here, this says I've eaten half. So pizza cut in half, ate that whole big half of it. This says I've eaten 3 slices out of 4 if the pizza had 4 slices. So let's make this first pizza have 4 slices. So really, that's the same as eating 2 slices out of the 4. Then you're adding, because you're eating from another pizza, 3/4, 3 pieces. And so in total, you've eaten 5/4 of a pizza, which is the same as 1 1/4. Okay, makes sense. You've eaten more than a whole pizza. So biggest thing, you need a common denominator. Now in high school math, we don't actually care about mixed numbers very much. I know in junior high and elementary, maybe, well, I don't know if you started mixed numbers in elementary, but in middle or high school, you're probably converting mixed number to improper fractions to mixed numbers a lot. We don't really need to do that much. Reason being, a lot of time in math now in high school, we're doing the fraction work, and then we're taking that fraction and doing something else with it. Or we're using it in polynomial or something like that, where we don't want a mixed number. So just be aware, you don't have to do that. This is your final answer as long as it's in lowest terms. Okay, so 7 and 3. So 3 doesn't go into 7, so we have to find our lowest common denominator. And because it doesn't go in, it's just going to be the product of those two numbers, 21. So now I have to find the equivalent fraction with a denominator of 21. Okay, so multiply top and bottom here by 3. Top and bottom here by 7. So now this is going to be 18 minus 21. 18 over 21 minus 14 over 21. And so my final answer will be 4 out of 21. And you can't reduce it. No common factors there. Okay, so that's my final answer. C, not a common denominator, 4 and 10. So your lowest one, Well, one possible common denominator would be 40. 4 times 10. You can always get a common denominator by multiplying them together. But is 40 the lowest common denominator? No. What do you think the lowest would be? 20, exactly. Because 10 has a factor of 2 and 5, factors of 2 and 5. And this has a factor of 2, right? 2 times 2. So there's one that's been repeated. So the lowest common denominator is 20. Now, if you used 40, it's not wrong, but you will have to reduce it at the end. So maybe you're saving yourself some time here. So multiply top and bottom by 5 to get 20, top and bottom by 2 to get 20 there. So that's 19 out of 20. Okay. And then with 3 fractions, same thing, you have to have a common denominator for all 3. So take a look at them. Oh, did I do something wrong? Oh, 29, thank you. Just seeing if you're awake. Thank you. 5 and 14 is 29. 15 and 14, sorry, 5 and 14 is 19. 15 and 14 is 29. Thank you. Okay, so then here with 3, take a look. I know that 2 goes into 8. So if I just had this as my question, my common denominator would be 8. Okay, but I have this 3. So really I'm finding the common denominator, lowest one, between 8 and 3. Well, 3 doesn't go into 8, so 8 times 3 is 24. So now I'm going to show each of these with a denominator of 24. Okay, so 8 times 3, so that's 15, right? 3 times 8 is 24, 3 times 5, hard to read my writing, is 15. Then 12 times 2 is 24, 12 times 1 is 12. And then 3 times 8 is 24, 2 times 8 is 16. And always remember your final answer, keep that same denominator. I'll get students that get the common denominator, they do all that hard stuff, and then at the end, they had 24 together 3 times. Or here they go 24 minus 24 is 0. Well, I guess in this case, kind of would end up with the correct denominator. But over here, they would get 40 in the previous question. Or they'd get 0 in the denominator if they subtracted them, which you can't have. So always keep that same common denominator and then go 15 minus 12 is 3 plus 16 is 19. Now it's 19. And you can't reduce that one. Okay. So common denominator is needed for adding and subtracting, preferably the lowest common denominator. For multiplying, yep. Oh yeah, you could do that. Yep. So then you would get 5 minus 4 is 1 over 8, right? So you'd have 1 over 8 plus 2/3. And then with the common denominator, it would still be 24. So that would be 3 plus 16 is 19. Yeah. You can do it in steps if you want. With multiplying, do not waste any of your time to get a common denominator. Okay? Because then that's really big numbers that then you have to multiply together. And typically when students do that, they forget to multiply the denominators and get it wrong. So don't spend the time. You do not need a common denominator. You're not adding or subtracting. You're just multiplying. So multiply numerators together, multiply denominators, and then reduce if you can. Okay, so I think I have this on here. So here, multiply the numerators is 6, denominators is 35, and reduce. But you can't. In this case, you can't reduce. What you can do is check and see if there's some common factors between the numerators and denominators and divide those out first. In this case, there isn't. 3 doesn't go into 5 or 7. 2 doesn't go into 5 or 7. So that's why you can't reduce it. Okay. So here, if I multiply right away, it's 18 over 30. And then I see, oh yeah, 6 goes into both of these. So got to reduce it, and that's going to be 3/5. Okay. Now, little bit faster way that some of you might be doing is to look and see 9. Is there a common factor between 9 and the denominators, 10 and 3? Well, yeah, 3 goes into itself. So I'm going to actually just write this question out again here. 9/10 times 2/3. Okay, so then I see, all right, 3 goes into itself once, into 9 3 times. You can only do this between numerators and denominators. 2 goes into itself once, into 10 5 times. So now if I multiply these together, I get 3 times 1 is 3, 5 times 1 is 5. So you can do that if you notice that there's common factors. If you struggle with that, then do it this way. Multiply the numerators, multiply the denominators. At least you've got the correct value. It's just not in lowest terms. Okay. C is pretty straightforward, but some people make it harder. They go, oh, 12 times 3/4. I'm going to multiply 12 times 3 and 12 times 4. Well, that ends up, if I reduce that, to be 3/4. Well, isn't that what I started with? How can you multiply 3/4 by 12 and get the same answer again, right? So be very careful. Think, always have your thinking cap on, right? So here, this is the same as, oh, I don't know what's up with my computer today. This is the same as 12 over 1 times 3 over 4. So that's going to be 36 over 4, which is 9. If you noticed right away that 4 goes into 12, you could do that like I did over on the right. 4 goes into 12 3 times. 3 times 3 is 9. 9 divided by 1 is 9. Okay, so always think what makes sense. I'm taking 3/4 of $12. It should be less than 12, but still be a decent amount, right? 3/4 of it. So 9 makes sense. And then dividing fractions, that's one step more than multiplying. Okay, if you think about the first one here, 8 divided by 1/4, it's saying how many 1/4 of a unit are in 8. There's a lot of them, right? How many, so 1/4, if you think about money, quarter is 25 cents. 0.25 is the same as 1/4. How many quarters in $8? Well, there's 4 quarters in $1, and you've got $8, that's going to be 32, right? So what happens here, again, is 8. You've got to take the reciprocal of the second number. That means you flip it. Flipping is the non-math word. And multiply, right? So back in junior high or middle school, they may have used the phrase kiss and flip. Back in the old days, when I was growing up, it's kiss and flip. Because the X symbol is a kiss symbol when you sign your a card. X's and O's. Kisses are X's and O's are hugs. And flipping means you flip the fraction upside down. So that's going to be 32 over 1, which is 32. Okay. Always the second fraction is what you flip. Okay. Eight ninths times, so kiss symbol, 3 over 2. So 24 over 18, and reduce that. 3 goes into, 6 goes into everything. Oops, I'm going to change it, but 4/3. Now, take a look at this particular question. If you had said, oh, I'm just going to divide 8 by 2 and 9 by 3, it works out. But it's very rare that that will happen. If it works for the numerator and not for the denominator, you can't do it. So if you did it that way, just realize that it's not always going to work. And then the last one is order of operations with fractions. So take a look, I've got subtracting and multiplying. Got to do multiplying first. So everything else, all of the other terms, you just copy out. And now I'm going to show that 3/8. And then I flip the 2/3, so that's going to be 3. Oh no, I'm multiplying, sorry. Okay, so I can do that step right away. I'm multiplying, so let's go. 3 times 2 is 6. 8 times 3 is 24. Or you could reduce it right away if you see that you can. If you didn't notice that, then it just takes an extra step. That's going to be 1/4. So you may have gone right from there to there if you notice that the 3 is divided out and the 2 goes into 8 4 times. Okay. But for sure you have to show that step, and now you need a common denominator. What's nice is 4 goes into 16, so that's your common denominator. So you multiply by 4 to get 16. So that's going to be 4 up top. Denominator stays the same. 5 minus 4 is 1. Okay. So just order of operations, multiplying before subtracting. In B, we've got brackets. So we've got to do the brackets before multiplying. Oops. Okay, so in the brackets, need a common denominator. Luckily, 3 goes into 6, so that's going to be our common denominator. So I'm going to need to multiply by 2, top and bottom. And then in the brackets, denominator 6, 5 minus 4 is 1. And now it's a multiplication question. 3 times 1 is 3, 4 times 6 is 24, and reduce that. Or you may have seen that 3 goes into itself once, into 6 twice, and gone right to the 1/8. Okay. So lots of things. So 3 things here. Rounding, decimal operations, except for dividing, and fraction operations. Okay.
So if you look at your package of notes, the next page is the practice, next 3 sides, okay? Then there are some puzzle sheets for sure. So for sure tonight you're finishing the practice, and for sure please do the rounding. And I think the rest is all fractions. I don't have any more decimal stuff. So at least choose one of the, I would say probably this page. So the rounding and the adding and subtracting, because adding and subtracting is the hardest. So make sure you get that done tonight. This, if you don't get it done, the last one, you can save that and do that when you have more time. Maybe tomorrow night. You won't have homework tomorrow night. You can catch up. And remember, part of your homework is D2L. Make sure that you get on there. The app that you can download on your phone is actually Brightspace. It's called Brightspace for D2L. Yeah. And so when you look at that, I think it's almost the first thing that pops up for most of you. If you get something that way you have to pay, it's not the right one. So it's free. Brightspace Pulse, I think, is what you want. You don't need the portfolio. Portal app for members doesn't make sense. And then it gets a Pulse checker for your, you don't want. Okay. The first one's always an ad. It's not necessarily what you need. So Brightspace, kind of orange with like electrocardiogram heart symbol, heartbeat symbol. Okay, so that's what you want to download. And that way you can access all the